I hope you still remember in the last week we talked about relational algebra. We mentioned some basic operators we can have in the relational algebra, which include the basic set operations like the union and the difference, as well as selection, which can be denoted by the sigma, right? And the projection denoted by the pi, the product denoted by this times. And we can also use a spatial operation. It's called renaming. It can help us rename the relation into a different one. And these are the basic operations. And based on them, we can further derive some more complex operations like the intersection and the complement for the sets, as well as different kinds of joins like natural join, equal join, theta join, semi-join, and etc. So in this week, we will cover all these operations for you and also provide you with some examples about how to use them to design some queries for us, which will be the foundation for the SQL to be introduced later. So the ideas in the design queries with this relational algebra can be implemented with SQL later. So if you can follow me, in this section, there should be no problem for you to write SQL in the future sections to be introduced after the midterm. In the last week, we also introduced the basic operations on the sets, right? We mentioned the union operation as well as difference operation. I hope you can still remember what we mentioned before, right? And you can go over the slides and the lectures in the last week to refresh your mind about these materials we have covered. We also have some reminder for you, right, to pay attention to, especially on the schema, in the input schema as well as output schema. And we also need to pay attention to the duplications, right? If they will do the duplication removal or not. So be careful about this kind of special points for the operations. Okay, so in this week, we will talk about some other basic operations we can use to design the queries. The first one we need to mention is about selection. In our database system, the tables we have can be very big, and we can have so many different data records or data tuples. And sometimes we may need to select some of the tuples which can meet our requirements or conditions. And then we need to use this selection operation to help us. This selection operation can return all the rows or tuples which satisfy a condition. Condition is some requirements we predefine for some tuples. And we can represent the selection. It can be formally denoted as a sigma with subscript C. The C denotes condition. It's a subscript. And then we have a parenthesis. We have R. R denotes a relation. So it is sigma condition on some relations, right? C is a condition. It can denote some like predicates, like some attribute equals to what, or less than what, larger than, or we can even design some more complex conditions by using this and or not in the condition. We will show some examples. And the input is a relation. It is R, right? So the relation will have a schema. And for this operation, after we do the operation on this relation R, we will have a output. So the output will still be a relation, right? You can remember this. And for the output relation, it has the same schema as the input relation. Because this operation do nothing changes to the schema. It only selects the data tuples, right? And let me provide you with a more concrete example. So let's say we have a data table about employees, right? We have like 4 attributes. We have SSN, name, department ID, as well as salaries of employees. And we also provide a table for the employees in our database system. We have 3 data records. The first one is about NX. The salary, his salary is 30K. The second one is Bob. His salary is 32K. And the last one is Chris. His salary is 45K, right? These are the data tuples we have in our database systems. And let's assume if you have an application and you plan to find all the employees whose salary is greater than 40K. Then how can we select? How can we find out which employees can meet our requirements? Right. So this is more like a query we plan to execute on this relation, the employees, right? We can do so, or we can represent this as an action by using this selection operation. We can denote this this query as a sigma, right? Sigma denotes a selection. We have sigma, then we have a subscript. It is salary larger than 40K, right? This is a condition. This is a condition. And then we have the employees. Employee is a relation, right? We define here. This is an employee relation. And we can find all the employees whose salary is larger than 40K by writing the sigma salary larger than 40K on the relation, on the employee relation. So by executing this query on the employee table, we can generate the output for this execution, which will be like here on the right hand side. It will still be a relation. It can still be represented as a table. Remember, for this operation, we do nothing changes to the schema, right? The schema will be still the same as the original one, right? The attribute names as well as the value types will remain the same for the output relation, right? However, for the data tuples we have in the output relation, we only have the employees whose salary is larger than 40K, right? Among all the three records we have in this employee table, we only have one single employee, Chris. His salary is larger than 40K, right? Then we can add this data table into the output relation. We have Chris as well as salary is 45K, right? Meeting our requirements. This will be returned as a result for this query. So you see, this query do the selection in the rows, right? In the rows of the data tables, it locates all the employees which can meet our requirements as specified by the condition, right? So this is about selection. And for this selection, the condition is very simple. It has only one single attribute comparison, right? And we can also provide more complex selections